Hello guys, welcome back to my channel, Mason African Motives, still focusing on mathematics for N2. So in this platform, actually, we shall be working on exponential equations, which is actually a continuation from the previous class that we had when we worked with the laws of exponents and applying the laws of exponents and so forth. So in this case, actually, what we need is to apply a condition where you are solving equations under exponents. So we are actually focusing with important questions so that we can be able to answer our questions from the exams which we are preparing, which is ahead of time. So actually, if you're part of this family, you can consider subscribing so that you become part of the family based on African Motives. So quickly rush through the part that we are talking about here of exponential equations. There are two actual considerations that we have. We have got the first part where we are given a condition where we have like bases. All right. When I am saying that we are given a condition of like bases, remember I'm saying exponential equation. So this is supposed to be an equation under exponents. All right. Like bases is a condition where I am given something like a to the exponent of x, which is equal to a to the exponent of y, like this. All right. These two bases are the same. As you can see, they are like, they are the same. We have got a and a there. Whenever you are given this condition, it means therefore x is equal to y. So what does it mean? When the bases are the same, actually it means the exponents are the same. So we are saying that when the bases are the same, equate the exponents. So these exponents, we are referring to what? To the powers. The powers that we are given. We've got the power of x here and the power of y. You equate those whenever you are given a condition that the bases are the same. You equate the exponents or you equate the powers. So this can help us to solve a lot of questions. In which manner? In this manner, if I am given a condition, let's say I am given 2 to the exponent of 3x, which is equivalent to 16. All right. The question will be asking you to solve for x. You are not told what to use, just solve for x. And you wonder, what can I do to solve for x? Which part can I actually use to solve such? All right, this is the idea, guys. Remember we said when we are given a condition of like bases, we can equate the exponents. But in this case, we have a base of 2, a base of 16. These are not like bases. But I can make these two bases to be the same. How can I make these two bases to be the same? This base of 2 and this number 16 to be the same. All right. As I can see, guys, I'm not going to focus on 2. Why? 2 is a prime number, a prime factor. It's already in its simplest form. As you can note, the only numbers that you can multiply to get a 2 is 1 and 2, and there's nothing that we can do on 2. So which means I'm not going to focus with these 2, but I'm going to focus with 16. So since my condition is of obtaining bases which are the same, these bases which are the same, since this is my consideration, therefore I'm going to consider 16 in base of 2, because already I'm given this base of 2 which cannot be simplified further. So I'm going to relate 16 back to base of 2, because that's your smallest number and it is in its simplest form. You can't do anything on this number, so you have to write 16 in terms of 2. So 16 is the same as 2 to the exponent of 4 from your calculator. That is 2 to the exponent. So how do you do this? Since you know that you are relating to base 2, you're going to try 2 to the exponent of 1. You obtain your 2, which is not 16. You try again 2 to the exponent of 2. you obtain a 4, 2 to the exponent of 3, you obtain until you obtain what? A number that is going to give you a 16. That is 8 here. Then to the exponent of 4, which is a 16. So that is the condition that you are trying using your calculator. So you're going to obtain 2 to 16 from 2 to the exponent of what? Of 4, because you are relating to base of what? Of 2. That is why you have to use 2, not 3, because there is no 3 here. There is no base of 3. You can't use base of 3 or base of 4. Okay, so that is the idea there. So 2 to the exponent of 3x is equal to 16. You say it is 2 to the exponent of 4, like this. So as we can see, we have written these two numbers in the same basis, which is the base of 2. So therefore, I'm going to apply this law that we said when the bases are the same, I am going to equate the exponents, because I've got this base and the base. I equated x and y, so I'm going to equate just using this law. I'm going to equate the exponents. Which are your exponents? Your exponents is 3x is equal to the exponent here is 4. So you equate these exponents like that. The moment you equate these exponents, guys, forget about this topic that we are talking about, which is exponents and logarithms. Forget about this topic. Relate back to your normal equations. How do you solve a normal equation like this? 3x is equal to 4. 3 is multiplying, so I have to divide by 3. So you remove this 3 by dividing, because it's multiplying. The moment I divide here, I'm going to be left with x, which is equal to 4 over 3. So that is what I'm going to obtain there, or it can be 1 and a third, still one and the same thing. So that is the value of x there. So are you seeing that to solve an equation, which is an exponential equation, when there is a condition that you can make the bases to be the same, that is like bases, you make the bases to be the same, then you equate the exponents. That is the idea there. So I want you to see that they can ask these questions now in different ways and formats. I just want us to focus with these questions here. All right, so there are a lot of cases that you're given to solve for x there. All right, so from these questions, let's start with the first question. We just focus with 1 or 2 questions there, then we move on to another part. 2 plus x is equal to 27 to the exponent of x. This is the question that we're given. Okay. So how do I solve this type of a question? This is the question that we are having now. All right. This is the condition, guys. We have got 9 as a base here, and we've got 27 as a base here. But these two numbers that I'm having, I can't write them in any of the bases, like either in base of 9 or in base of 27. But I can choose another base. So I'm going to relate to this number 9. Which base can I use to obtain a 9? And which base can I use to obtain a 27, which is the same base? So you'll see that relating these numbers, 9 and 27, guys, we can see that there's something to do with 3 there. So we are going to use the base of 3. So this 9 in base of 3 is 3 to the exponent of what? Is 3 to the power of which number that is going to give us 9? So this is 3 to the power of 2, which is going to give you 9 from your calculator. 27 is from 3 to the power of 3, which is going to give us 27. So as you can see, these two numbers can be written in the same base, which is the base of what? Which is the base of 3. So if they can be written in the same base, which is the base of 3, therefore I'm going to write this 9 as 3 to the power of 2. Remember, 9 is 3 to the power of 2, like this. But there is something here which is weird, because there was already an exponent which was there, which was 2 plus x. So what am I going to do with this exponent? Because it was already there, I'm just going to multiply it back like this. 2 plus x, I write down my exponent as it was. So this 3 to the exponent of 2 is the one that is now replacing 9. In place of 9, you substitute 3 to the exponent of 2. Okay? We move on to 27. 27 is 3 to the exponent of 3. So it's going to give us 3 to the exponent of 3. This is your 27. But take note, there was already an x which was there. So I'm going to multiply to that x. Just like what I did here, I had to multiply with 2x, 2 plus x. The same thing, I have to multiply by x here. All right. So multiplying by x, what am I doing, or what am I going to achieve from this part? The moment I see this condition here, I'm now glad that my answer is going to be final, because these two bases are the same now. So we are back to that condition where we were talking about like bases. Whenever you are given like bases, equate the exponents. So you are going to equate the exponent. What is your exponent here? Your exponent is 2 into 2 plus x. That is your exponent, which is equal to, what is your exponent on the right hand side? Is 3 into x. This is what you're going to equate. Now forget about exponents, just like what I said in the previous part, where I was saying that whenever you're given this condition like this, you are now back to normal equations. As you can see, it's a linear equation. I have to expand brackets, 2 times 2, which is 4, 2 times x, so you multiply everything by 2, so it's 2 times x, which is 2x, which is equal to, we've got 3 and x, so 3 times x, which is 3x. So how do I solve this equation? Remember, I have to collect like terms. So which are the like terms? These are the terms which contain x. We've got x here and x. So 4 is equal to, if I transpose this to the right hand side, it's going to be a negative. It was a plus here, so it's going to be a minus. So it's now 3x minus 2x, of which 3x minus 2x is going to give us x. So as you can see, if 4 is equal to x, it simply means that x is equal to 4. It's one and the same thing. So our x is going to give us a 4 there. So that is the idea there. That's how you can easily solve such typical questions. Okay, so that's the idea. Let's see this one on number 5. Okay, I think the other ones, they're direct. Just like, let's see number 5 there. On number 5, we are given 3 to the exponent of 2x plus 1, which is equal to 81. This is what we are given on number 5 there. So 3 and 81, these are the bases that we are given. Take note, the question was solved, the exponents we are solving for x. So you have got 3 here, and this is 81. So which base am I going to use? As you can see, 3 is the same as that part where we had 2. It's already in its simplest form. There's nothing I can do there. So I'm just going to leave it. So I'm going to write this 81, but now I have got a reference base that I'm going to use, because I've got this 3, which is in its simplest form. So this is going to be my reference base. So my reference base in this case is the base of what? 3. So now I'm going to try from my calculator 3 to the exponent of 1 until I obtain an 81. So you are going to see that 3 to the exponent of 4 is the one that is going to give you an 81 there. That is where you're going to obtain an 81. So it's a matter of trying. You're trying 3 to the exponent of 1, that is 3, 3 to the exponent of 2, 9, 3 to the exponent of 3, 27, and so forth until 81. So 3 to the exponent of 2x plus 1 is equal to 81, which is this. My 81 is 3 to the exponent of what? Is 3 to the exponent of 4. I now replace in place of 81 with 3 to the exponent of 4. So by doing this, guys, I'm done, because the bases are the same. So I'm going to equate the exponents. 2x plus 1 is equal to 4. Done. So transpose, just like previous part, collect like terms. So 1 is going to be taken to the right hand side because there's a number 4 there. So 2x is equal to, if I transpose this, is going to be 4. minus 1, which is a 3. So how can I find x? I'm multiplying here, so I'm supposed to divide. So the moment I divide, I'm going to obtain an x, which is 3/2. So that is the value of x that you're obtaining there. So as you can see, guys, that's the consideration. So they can be different types of questions. They just now try to confuse you because of the way they can ask these questions, because they can ask you this question like what we have there on number 10, where we are given that 2x. Actually, this one was a mistake because we need an exponent. We need an exponent, sorry. So it's supposed to be on number 10. It's supposed to be like this. They wrote that in a wrong format. It's supposed to be 2 to the exponent of x is equal to 1/8. All right, so this here, this is your number 10 there, because we are working with the base exponent. So just correct that one so that it can be under the topic that we are talking about here. All right, so this is what we have, guys. As we can see, we've got a base and an exponent, but here we do not have that condition. It's a fraction, this one. We need a condition, guys, where there is a base and exponent, and on the other side also a base and an exponent. So how can we do that from this 8? All right, we know that whenever you're given a fraction like this, you can rewrite this from the negative, from the laws of, remember what we said from our laws of exponents. X to the exponent of a negative like this is going to give us 1/x to the exponent of a. When it is a -1 like this, x to the exponent of -1 is going to give us 1/x like that. So if this is the case, guys, this is what we have here. We've got 1/x here, which is the same as 1/8. So if this is the case of 1/8, and I am having this from 1/x to x to the exponent of -1. So I can do the same. This is my x, which is 8. So it's going to be 8 to the exponent of -1. Just a vice versa, 1/x, x to the exponent of -1. Okay. Now I have a base exponent. So which means I can make these two to be in the same base to give us like bases. So which base am I going to use? Definitely it's base of 2. So it's 2 to the exponent of x is equal to 8 in base of 2. That's 2 to the exponent of 3. Try from your calculator. It's going to give you 2 to the exponent of what? Of 3. You multiply by -1, which is the exponent aside there. All right, so let's simplify, guys. 2 to the exponent of x is equal to, you multiply 3 times -1. So from your calculator, that is -3. 3 times -1. All right, that's -3. So we are now back. The bases are the same here. So I'm just going to equate the exponent. So therefore, x is equal to -3, of which we could have just done it from this part here, because we already saw that these bases are the same. So we could have done it from this stage. We could have said x is equal to 3 times -1. Still, we're going to obtain the same thing, which is x is equal to 3 times -1, which is -3. All right, so that's how they can ask this condition where you are given such typical questions. So in order for you to actually answer these questions, it's a matter of working with different types of questions that you actually have. All right, so another type now of questions is whereby we'll be having fractional powers. That's another type where you are going to be having fractional powers. All right, what am I going to do on this condition now where I'll be having a fractional power? All right, what type of a question can it be? Let me give it by an example. Maybe it can be easier. If I am given x to the exponent of 2/3, which is equal to 16 like this, and the question is still to solve for x. All right, this is what you're going to do. These are the stages that I want you to take note. All right, Since there is our x now is in the base, as you can see, our x is in the base, guys. It's no longer a condition like what we had where the base was just having numbers 2 to the exponent of 2x is equal to 16. These were numbers and our x was in the exponent. This time our x is in the base, so it's now difficult for us to apply that last concept. You can't apply that. So what are you going to do? All right, you're going to find the inverse of the given exponent. All right, find the inverse of the given exponent. All right, and multiply to the exponents of both terms, of both given terms. All right, so I want you to note from this, you have to find the inverse of the given exponent and multiply to the exponents of both given terms. What are you multiplying with? You're multiplying with the inverse. This is the inverse that is actually multiplying both. So how do I determine this inverse? Because like this is the exponent that I'm given, and my exponent is 2 over 3. So the idea there is, the question is, you have to find the inverse of this number first, which is the exponent. All right, so this is how you find the inverse. To find the inverse of a number, is simply 1 over the given number. That's the inverse of a number. 1 over that number that you want to find the inverse. So in this case, we want to find the inverse of 2 over 3. So it means 1 over 2 over 3, like this. This is what you're supposed to, you're dividing 1 divided by 2 over 3. That is the inverse of 2 over 3. So I want you to use your calculator, 1 divided by 2 over 3, and make sure that this is in the bracket, or you can use your calculator like this, 1 divided by 2 over 3, like this. That's the inverse of a number. Okay, so you're going to obtain 3 over 2 from your calculator. All right, so we are given that we have to find the inverse of this number. Then we multiply to the exponents of both terms. Okay, this is the inverse of the number, which is 3 over 2. So we are going to multiply with this inverse 3 over 2 to both exponents. Okay, but looking at the question here, this is my first term, this is my second term. Yes, here I can see that the exponent is 2 over 3, but what about this one? Because this is supposed to be multiplying exponents, not these numbers, but the exponent, which is the power. So 16, which power do we have on 16? 16 is the same as to the power 1. Any number means to the power 1. All right, so this is what I'm going to do. I'm going to take this inverse, which is 3 over 2. I multiply it to the exponents. So this is my exponent, 2 over 3 times the inverse 3 over 2. Okay, take note, guys, you're multiplying the exponents, not the numbers, but the exponents, which is equal to 16 to the exponent of 1 times 3 over 2, because here there is a 1, so it's 1 times 3 over 2, which is just like 3 over 2. There's no effect there. Okay, so if you multiply properly from your calculator, 2 over 3 times 3 over 2, you're going to obtain a 1. So this part is going to give us a 1, so which means we are left with x to the exponent of 1, which is the same as what? Which is the same as x. Okay, so x to the exponent of 1 is equal to 1 to the exponent of 1 times 3 over 2. So because these are multiplying, so it's just 1 times 3 over, of which 1 times any number, it remains as it is. So it's 16 to the exponent of 3 over 2, like this. This is what you're going to have. So at this stage, what am I going to do? Already, guys, remember what I want to solve. I want to solve for x. So x to the exponent of 1, already that's my x. So already I'm having the x there. So this x means it's equal to 16 to the exponent of what? 3 over 2, of which you can use your calculator. 16 to the exponent of 3 over 2. That is what you're going to do from this part. So that is the idea. So you're going to obtain a 64 there if you use your calculator properly. this is going to give you a 64. So take note, guys, 16 to the exponent of 3 over 2, like this. This is what you're supposed to indicate on your calculator, okay? That is where you are going to obtain this 64. So that is the idea there. In exam, these are the stages which you can actually take so that you actually understand what you are doing there. There is this question here on this fractional where we are given a fractional exponent. There is this question where they just want to try to confuse you. It's given as 2x to the exponent of a half, like this, which is equal to 10. That's the question that you're given. All right. So using the same consideration like what we did in the previous part, what am I going to do in this case? Okay, here, take note, there is a number which is affecting x, this one. So actually, I can first get rid of this number that you're given. So how can I get rid of this number? I can divide by 2. Okay, so the moment I divide by 2, I'm cancelling. This was multiplying and it has nothing to do with x, so I can divide these 2. I'm left with x to the exponent of 1 over 2, which is equal to 10 divided by 2. From your calculator, this is 5. So when you have a condition of having a single term on the left hand side and another single term on the right hand side, there we can now apply the concept that we talked about of finding the inverse. Okay, so just like what we did, guys, we said we're going to find, we want to find x, but there's a fractional exponent here, so we're going to find the inverse of this number here. So, and I said the inverse of a number, it means 1 divided by that number. That's the inverse of what? Of 1 over 2, which is going to give you a 2, or you do it like this, 1 divided by 1 over 2 from your calculator. This is going to give you a 2. That's the inverse of a number. Okay, so once you obtain the inverse of a number, we are going to multiply to the exponents. Take note, to the exponent. This is your exponent here, which is your power, 1 over 2, times the inverse. We obtained our inverse, which is 2, or someone can write this as 2 over 1. It's still one and the same thing, but 2 over 1 is same as what? Is same as 2, okay? Which is equal to 5, is same as 5 to the exponent of 1. So we are going to have 5 to the exponent of 1, that is our exponent, times the inverse. Our inverse is 2. All right. So just like the previous part, if you are to multiply this half and 2, you're going to obtain a 1. Half times 2, that's a 1. So x to the exponent of 1 is equal to 1 times 2, that is a 2 there. All right. So this x to the exponent of 1, already that means x, because any number to the exponent of 1 remains as it is. So x to the exponent of 1 remains as what? Remains as x. But we are going to simplify 5 to the exponent of 2. So from your calculator, or by just knowing this, we know that 5 times 5, that is what? That is 25. So this is going to be the value of x that you're going to obtain from this equation. So as you can see, guys, it's a matter of working with different types of questions. It's not like this is the original thing of doing it. It's a matter of dealing with typical types of questions. By working with these different types of questions, definitely you will end up understanding what you are doing. So like I said, guys, they can ask these questions in different ways and different manners. So we shall meet again in another class working with different questions, but now we shall be working on a different platform, which is on logarithms, separately on logarithms. Okay, so that's another type of question that I want us to work on, but let me show you that there are so many questions that you can try. If there can be any questions which are of challenge from this part, we just work from exercise 4.8 there. These are the questions. That's how they can ask these questions. So you can just try as many questions as possible there. All right. So this is what you're going to have here. Just like what we did in the previous part, are you seeing that there's a 2 which is multiplying and it's not part of x? So we can divide by 2 both sides. Okay. The moment I divide by 2, it means I'm cancelling there. So I'm going to be left with the bracket of x minus 2 to the exponent of 1 over 3, which is equal to, if you divide properly, 8 divided by 2, that's a 4 from your calculator. Okay, so this time, guys, please be careful, be very, very careful there. X minus 2, it's a bracket, and that exponent is affecting the bracket. So there's nothing that we can do but to find the inverse, because we need to find the x, and it's just like the same thing because it's in a bracket. It's different from the previous question. This one is in a bracket, so you're going to determine, just like what we did in the previous parts, you're going to find the inverse of 1 over 3. Okay, and what is the inverse of 1 over 3? We said you're going to divide 1 by 1 over 3, which is going to give you a 3 from your calculator, or it's 1 divided by 1 over 3 like this, which is going to give you a 3 again. So that's how you find the inverse. 1 divided by that number that you want to find its inverse. Okay, so since this is my inverse, which is 3, I'm going to multiply both x minus 2 to the exponent of 1 over 3 like this, times the inverse, which is 3. So you're going to multiply by the inverse. Okay, which is equal to 4, which is the same as 4 to the exponent of 1. Okay, so it's going to be 4 to the exponent of 1 times the inverse, which is the inverse is 3. So now, as we can see that we can actually simplify this. 1 over 3 times 3. This is going to give you a 1 from your calculator. So you're going to be left with x minus 2 to the exponent of 1. All right, which is equal to 1 times 3, which is a 3. So it's going to give us 4 to the exponent of 3. All right, then what can I do now? Because I'm given x minus 1 to the exponent of 1. Okay, remember, guys, I always say any number to the exponent of 1 remains as it is. 2 to the exponent of 1 is 2. 5 to the exponent of 1 is 5. Just like this 4, it was 4, but we wrote as 4 to the exponent of 1, which means this bracket to the exponent of 1 is just the same as x minus 2. There is nothing there. It's just going to remain as x minus 2 because it's to the exponent of what? Of 1. Okay, which is equal to 4 to the exponent of 3, which is going to give you a 64. All right, so transposing this, we are going to find the value of x, because we are going to transpose minus 2 to the right hand side, which is going to be a plus. It was a minus. The moment it crosses the equal sign, as long a number crosses the equal sign, it changes its sign. So it's now a plus 2. So 64 plus 2, which is going to give us a 66. All right, so that is the idea there. That's how you actually solve these questions. So like I said, guys, I think I showed you the exercise on 4.8 that you can actually revise on. But we are going to meet again in another class. While it's now we'll be working on logarithms as our third class, working on logarithms, applying now logarithms from these exponents. We are going to see the importance of everything that we did here. All these exponential equations, we are going to see the importance of them when we'll be working with logarithms. There is no way you can understand logarithms without the basic understanding of exponential equation or exponents. You need the basic part of what? Of exponents. So that's it, guys, from Mason African Motives, working on daily revisions for mathematics N2 so that we can prepare ourselves for the exams which are ahead of time. Till we meet again.